Okay, so we're looking at the fourth question from the University of Washington's Math 120 Pre-Calculus Midterm 2 from winter quarter of 2016. So now, given our formula for f, we need to try to model f inverse. So writing inverse functions is relatively straightforward. We can start by writing this as y equals this. Now, to find the inverse function, we'll swap the roles of x and y and resolve for y. So I can write this now as x equals 14y plus 40 over y minus 7. And now I have a little bit of algebra to do. I can write this as, let's say, xy minus 7x equals 14y plus 40. I want to solve this for y. Let me bring the 40 over to here and the xy over to here. I get that negative 40 minus 7x is equal to 14 minus x times y. I brought the xy over here and I factored I factored a y out of both of those terms. So now I want to solve for y here. What I'd like to do is just divide by 14 minus x. The only thing that has me a little bit concerned here is that whenever I want to divide by something like this, I have some problem that I'm potentially dividing by 0. In particular, if x is equal to 14, then dividing by 14 minus x here is quite problematic. I know that there's a vertical asymptote at x equals 7. So if this had been asking me to divide by, say, 7 minus x, I would have been a little bit happier. So I'd like to write now that I'll say y equals negative 40 minus 7x all over 14 minus x. And what I'd like to say here is then that f inverse of x equals this term here, which I don't like how many negatives there are floating around here. Let me pull a negative out of both of these terms and a negative out of both of these terms and cancel those negatives. I can rewrite this as 7x minus 40 over x minus 14. But I do actually feel like I need to do something about the fact that when I plug in x equals 14, this doesn't compute nicely. Oh, no, this is okay, just fine. In fact, what I said about this vertical asymptote a minute ago was bogus. So I have here that f inverse of x is 7x minus 40 over x minus 14. The concern here is about this fact that I was potentially dividing by 0 here. But if you actually consider how this graphs the original function, the graph of the original function is going to have this vertical asymptote at x equals 7. It's going to have this horizontal asymptote at y equals 14. In particular, you can see that as x gets really, 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 really large, this 40 and this negative 7 starts to become insignificant. If I imagine x is, say, 1 billion, then this is 14 billion and 40 over 1 billion minus 7, which effectively is just 14 billion over 1 billion, in other words, is just 14. So I'm going to find that my function will approach this value of y equals 14. So this graph is going to look something like this. And I can see that I'm actually feeling okay now about this x minus 14 value here, because I don't want 14 to have an inverse. In particular, there is no x value that would lead to f of x equaling 14. Although I fumbled a little bit as I was doing it, what I'd like you to really make sure that you take away from this process is when you do divide by something like this, you get to a situation where you want to divide both sides of the equation by 14 minus x, you do really need to pay attention to whether you're dividing by 0 or not. And you do need to come up with some reason why this dividing by 0 is not actually problematic. So we've written f inverse. That's that.